Now, I want to continue on with our look at the AWS offerings in the heading of messaging. And the last day, I started to introduce the second main messaging uh, service, which is called SNS. So I want to continue on looking at that today. And in relation to the lab, if I just go into it for a moment, I've added two new sections here from last week. And so I think when you've completed all of these sections, then you can submit this lab. Just note though that there are going to be some other sections that I will add on down here next week, and they are going to be relevant to the second assignment. So back to the slides here. So really, I only began to introduce SNS the last day. And SNS is what's described as a pub sub messaging service. Pub sub is a kind of generic term that you can hear or you would hear outside of the AWS platform. And essentially, pub sub is short for publisher subscriber. But whenever you hear pub sub, what that implies is that the sender of the message wants multiple receivers potentially to receive that message. That's different from SQS. SQS is a sort of a one-to-one type of messaging middleware in that the consumer only wants one, sorry, the producer of the message only wants one consumer to receive that message. Whereas with SNS, which stands for Simple Notification Service, the sender of the message wants many receivers to process the message. Okay, so again, SNS is quite an old service, 2010, which again significantly predates the whole serverless model. Although in the very second bullet point there, I am categorizing it as serverless, but that's simply because we don't have to configure in any way the SNS server, even though there is an SNS server running somewhere in the cloud on our behalf. All we've got to do is configure the piece of middleware that's taking the messages and sending them out to the other end, if you like, as you'll see. So we don't talk about queues in SNS, we talk about topics, but a topic is essentially the same idea as a queue. And you saw when we were looking at the SQS service, all we really had to do was declare a queue, even though there was an SQS server running somewhere managing those queues. Well, in the SNS world, we create what are called topics, and the SNS server manages the topics for us. So also just the language is slightly different. In the SQS world, we talk about producers and consumers. In the SNS world, we talk about publishers and subscribers. Yeah, publisher is the component that's sending messages to a topic, and a subscriber is receiving those messages. So topic then is, as I said, is a third term that we use in the SNS kind of world. Many subscribers have already said that. Each topic subscriber gets all the messages that were sent to the topic. The subscribers themselves could be, there are lots of options available to us. Obviously, Lambda can be a subscriber, but we can actually have an SQS queue as a subscriber. In other words, SDS and SNS topic might send a message to an SQS queue, and we'll see that a lot actually. That kind of combination is used a lot. Or an API gateway could be a subscriber. A Lambda, obviously, as I said. There are other options as well. We could have the SES service, which is the simple email service as a subscriber. We won't get to look at that. We won't get to look at SMS either. So anyway, there are lots of options available to us in terms of how we plug in or what type of subscribers we can plug into an SNS topic. On the producer side, equally, there are lots of options available to us. Again, the obvious one is a Lambda function can be as a publisher, uh, can send messages to an SNS topic. But as you will see in the lab, you can actually get S3 to also send messages to an SNS topic. The idea, for example, would be when a file or object is uploaded to an S3 bucket, maybe we want that to trigger the S3 service to send a message to an SNS topic. And then we would have subscribers to that topic, which would process that message in some way. And as I said, that's what essentially is kind of what you're doing in the lab, and it will be a big part of the second assignment as well. CloudWatch alarms can be publishers, and there's other options as well. So it's lots of flexibility available to us. As with everything on the AWS platform, there's lots of encryption kind of built in for free. So there's in-flight encryption. So that means as our messages are being transmitted from the publisher to the topic, those messages are encrypted. And equally, when the messages are being sent from the topic to the subscriber, they are encrypted. The messages will be at rest for a very short period of time in a topic, and they're also encrypted there. So that's very similar to what happened in the SQS world. The only thing is messages don't persist as long in an SNS topic as they do in an SQS queue. Message filtering, which is something that we look at quite a lot actually towards the latter end of this set of slides. The idea there is that you can specify a filter which reduces the number of messages that are actually received by a subscriber. So that's quite a useful feature to have. Obviously, lots of security built into the SNS service. All the obvious kind of things. For example, if you've got a Lambda, for example, that wants to publish message to an SNS topic, it needs to have the necessary IAM rights to do that. Similarly for, if it's S3 or any of the other publishing options, they all need to have the appropriate IAM policy to do that. Equally, if you want to share an SNS topic across multiple AWS accounts, then the other accounts, AWS accounts, need to have the necessary permission to essentially either write to your SNS topic or receive messages from your SNS topic. We won't see that, but we certainly will see the first one here. Auto scaling in the sense that SNS can handle any volume of messaging, essentially. Obviously, there's an absolute upper limit, but it's something that we never need to worry about. It's kind of built in. There is a DLQ option. You remember DLQ stands for dead letter queue. But that option is not as obvious as you might think in the SNS world. It's something I'll come back to later on, explaining where DLQs fit in with the SNS kind of service. So I did already mention this term topic. So I'm just saying here, an SNS topic it's a logical access point that acts as a communication channel. Yeah, channel is the word that's used as well. Maybe when we're talking about pub sub type services, as in we write messages to a channel and we read messages from a channel. So channel and topic can be used interchangeably. And the image then shows you this idea of, single publisher although you could have multiple publishers publishing to the same topic. But on the subscribing side, you can have many different subscribers. And again, without uh, repeating it too often, each of these subscribers, if you have, will receive every message that is being sent to the topic. And again, the variety of subscribers is illustrated here to reinforce it. You could have multiple Lambda subscribers. It's not the idea that you can only have one Lambda subscribers. You can have multiple. Equally, you could have multiple SQSQs and so on. The kind of 101 illustration. So supposing we've got this basic kind of architecture, our publisher, just for simplicity's sake, is going to be the AWS CLI. We've got an SNS topic, and we've got a Lambda that's a subscriber to this topic. Yeah. How do we describe this architecture in our CDK code? Again, it's fairly predictable now at this stage, given that we've done quite a lot of CDK code at this stage, and we've seen how to use SQS. The SNS programming model is quite similar. So just to walk our way through the code, this is us declaring an SNS topic. So it's as simple as that, right? There are other properties, but I think in most cases, we don't need to worry about the other properties. So that creates our topic or our channel. Let's supposing this is our Lambda function that we're talking about over here, the subscriber. I've collapsed some of the detail of the Lambda because there's nothing different in this Lambda from any other Lambda. This is the key line then that connects my Lambda as a subscriber to my topic. Yeah. And you note here that I'm saying I'm creating a new Lambda subscriber. So there's Lambda subscriber, SQS subscriber, etc., etc. There are different types of subscribers, as I've already mentioned. So it's as simple as that, really. I'm outputting the ARN of the topic, the Amazon resource number of the topic, so that I can use that from the CLI. And do I show you how to do it? I don't have the CLI command, but oh, there it is here, actually. Sorry, yeah. This is how we write a message to an SNS topic from the CLI. And typically what we're writing is some sort of JSON structure. So again, you'd put your JSON structure into a JSON file, and we're just referencing it from here. So it's as straightforward as that, really. What I'm showing you here is the console log of the event that my Lambda subscriber receives. And if we just read this line here, right, I'm saying a Lambda subscriber receives a batch of messages. So that's similar to SQS, but I've actually got a question mark here after batch because it actually turns out that it may look like it's receiving a batch of messages, but really the way SNS works, especially when you've got a Lambda subscriber, every time a message is written to an SNS topic, SNS automatically tries to send each message individually to the subscribers. It doesn't sort of wait until it has a bunch of messages and then send them to the subscribers. It sends the messages as it receives them from the publishers. Now, I don't know why, even when you read the documentation, it talks about your subscribers receiving a batch of messages. I've seen kind of contradictory articles on the web about this, but from playing around with it, it certainly seems like it receives each message individually. Although when you look at the event object of your Lambda subscriber, and if we look at the detail here, you see we've got the records, and records is an array. And that was very similar, identical really, to when we were looking at our Lambda, which was receiving messages from an SQS queue. And we showed when we were using SQS that we illustrated where our Lambda consumer, queue consumer, was indeed receiving batches of messages. But every time I've played around with this using SNS, this array never has more than one entry in it, one message in it. And that leads me, and not just me really, but from reading around this, to conclude that an SNS Lambda subscriber will only ever receive one message at a time, even though it looks like it's receiving an array of messages. There's always only one entry in the array. That's really why I've put the question mark here after the word batch. One other thing I didn't actually mention, if I go back to here, right, for example, you might remember with SQS. So if this was an SQS queue here, and I had a Lambda subscriber, for example, sorry, a Lambda consumer to my SQS queue, then we know that the way it works is the Lambda service periodically polls SQS for messages, and it receives a batch and then it passes them on to the Lambda. That's not the way SNS works. There's no polling going on here. The way SNS works is when a publisher writes a message to SNS, SNS actually invokes or sends the message to the receiving service, the Lambda service, the SQS service. So it's actually kind of pushing the messages out to its subscribers. Whereas with SQS, these components over here have to periodically poll SQS for messages. So that's an important point, distinction between SQS and SNS. SNS always initiates the sending of the messages to its subscribers. And as I've already said, it looks like that every time it receives a message, it tries to send it out straight away. Okay, so that's fine. So this is what an SNS message looks like when it's received by a Lambda consumer, albeit it's within the event object. And I haven't shown you the contents of this file, but it's just, in fact, I can show you what the contents is. If we go over to here, we've seen it before actually. If I go to here, there should be an address field in there actually. Can I recover that? Yeah, this is what the message looks like. Yeah, so nothing unusual there. And we can see that's when we look closely down here, we can see that that is the actual, in this case, it's the message attribute, within this larger kind of structure. And again, it's serialized, so we've got to be aware of that, and we've got to deserialize it within our Lambda to process it. I'm not going to bother running this example. It's a trivial example, so we'll just we just push on from here, I think. Okay. Whenever we're talking about the pub sub idea, this term, the fan out pattern, is a term that we hear a lot as well. And essentially, fan out and pub sub, they kind of mean the same thing. What the fan out pattern is emphasizing is this idea that you can have multiple subscribers, each of which will receive every message that's sent into a topic. Now, in this image, I'm showing you the 3 subscribers, and they all happen to be SQS queues, but it doesn't have to be. Fan out doesn't imply that the subscribers are only SQSQs. Fan out simply means that, you can have multiple subscribers, as I've been re-emphasizing probably too many times at this stage. If a subscriber is an SQSQ, then the assumption is, I guess, that you do have a lambda here, and similarly here and here. And the relationship between this lambda and this SQSQ is as we've described last week and the previous weeks. So there's nothing unusual. There's still polling going on here between the Lambda service. And again, we kind of imply that the Lambda service is managing my Lambda instance, my Lambda function instance, and there's polling going on here. So just another name for this idea of having multiple subscribers is this fan out pattern. Let's look at an example of that. And I'm just describing the architecture using text in this case. So again, for convenience, my publisher is just going to be the AWS CLI. It's publishing to a topic. My topic has two subscribers. One is an SQSQ, the other is a Lambda subscriber. And I also have a Lambda over here, which is a consumer of the SQSQ. Right? So two different types of subscribers, but we would still call this kind of an example of this fan out pattern because we've got more than one subscriber to our topic. And as we already know now, whenever I publish a message to my topic using the CLI, this Lambda is going to receive that message, and eventually this Lambda will also receive the message. I say eventually because, okay, the topic is going to write it to the queue, but because of the polling relationship that's between these two, it's only when the Lambda service does eventually decide to poll the queue that it will receive the message that was originally written to the topic and then pass it on to the Lambda. So we will step our way through this example. Now I've already deployed it. And if I switch over to this project, so I'll just scan down through the CDK code first. There shouldn't be any surprises in the code that we'll glance through here. So here I'm creating my SNS topic. Here I'm creating an SQSQ. This is a Lambda, and just based on the name, this Lambda here is the one that is a subscriber to my topic. Okay, so this Lambda is this Lambda here. I've got a second Lambda, and this Lambda, well, you've guessed it, represents this one over here. And what's left now is that we need to kind of hook all of these things up. So that's what's going on in the rest of this file. Here I'm connecting what am I doing? I'm connecting the Lambda subscriber to my topic. We can ignore all this stuff here for now. I'm adding a second subscriber to my topic, and in this case, it's an SQS subscriber. Again, we can ignore all of this for now. So I've now connected my two subscribers to my topic. In other words, I have connected this to this and connected this to this. All that's left is I need to connect this to this. And we know how to do that from earlier lectures. And that's all that's going on here. And I'm just outputting the ARN of the topic so that I can use it from the CLI. So I've already deployed it, and I want to send, let's say my message is my message is the one that we've been using all along. So this is the message that I want to publish. So let's do that. And for convenience, this command here is the one that I want to use. I just need to replace the ARN. And I'll get my ARN from here. Grab the command. And run it from here. Now if I refresh my logs, I'm only getting one Lambda log. There should be two. The reason the second one isn't appearing is because this Lambda log here, or CloudWatch logs for my Lambda, that is for uh, this Lambda. You see, it receives the message before this one because, again, because of the polling that goes on here. So there is a time delay before this Lambda actually receives that message. But this one almost receives it immediately. Once I publish it, SNS tries to push that message to the subscribers. And I've seen the log appearing for this one. It has also pushed it out immediately to the SQSQ, but we don't see the CloudWatch logs for this Lambda until after a certain time delay. And I guess if I go back now, I should see both logs at this stage. Yeah. And just based on the names that I gave them, so this is the CloudWatch log for the Lambda that's a direct subscriber to the SNS topic. And surprise, surprise, when we go into it, and I talked about these logs the last day. So it ran this is a cold start of this Lambda. It ran the initialization code. Then it started to execute the Lambda handler itself. And okay, we didn't look at the actual Lambdas, but I think there's nothing in them other than console logs. Let's just check the Lambdas. So this is the one I'm looking at. Yeah, this is the one this is the Lambda that's a direct subscriber, and it has a console log, and we can ignore this stuff for now. The other Lambda, which is this one, that's the one that's linked to the SQSQ. And again, it just has a console log and nothing else. But again, if we look at the console log from the Lambda subscriber, so I'm making a distinction between the Lambda subscriber and the Lambda consumer. The subscriber is the one that's connected directly to the SNS topic. The Lambda consumer is the one that's linked to the SQSQ. So if I expand this, again, it looks like my Lambda subscriber is receiving an array of messages, but I've already emphasized that There's never going to be more than one entry in this array. And the actual body of the message, there's quite a lot of metadata added to the message by SNS. So we really have to kind of drill down into it. Let's see, can I find the actual message itself? Where is the message? Oh yeah, there it is there. Sorry, here. Okay, so it's very deep within the object structure within my records array. And okay, that's that. And then if we look at the other Lambda, the one that's connected to the SQSQ, which is let's see, it's which one is it? This one, yeah. And look at the stream. And here's the console log. And it's the same. In fact, when a message goes from a topic to a queue to a Lambda, there's actually a lot of metadata added into that message. And so it's all buried somewhere within here. In fact, body is the key part. And if we look within body, can I find it again? You can see here, where is it? Yeah, you can see the actual messages. It's there. But again, it's serialized within a serialized body. So there's a lot of parsing that you have to do in order to get at the actual message. And you need to study that obviously in your own time. So that's fine. That seemed to work. I published the message and it got through to both of my subscribers and eventually finished up in both of my Lambdas. Okay, so in the screenshot, I'm just showing you, in this case, I'm showing you the structure of the event object for my Lambda subscriber. That's the one connected directly to the SNS topic. And in this screenshot, I'm showing you the console log from the Lambda that's linked to the SQSQ. And you've seen that kind of live as well. The SNS envelope, I just referred to this there in passing. So here I'm saying that the SNS wraps the source message. So the source message in my case was what was sent by the AWS CLI. SNS wraps the source message in an envelope before it sends it to the SQSQ. And so that's why eventually when the Lambda that's connected to the SQSQ, that's why when we look at the queue message, we have to dig down into that message before we get at what I'm calling here the source message. Because the source message is wrapped inside what we call an envelope. And, that's kind of confirmed from here, right? Is it confirmed? Yeah, like, my message is buried inside here, but all of this kind of stuff here is what I'm calling the envelope. In fact, I think I have a screenshot of it. If I go on to, yeah, here's a better screenshot of it. So again, this is the console log from the Lambda function. That's a consumer to my queue, and the queue is connected to the topic. So the outer box here is the message that was sent to the SNS topic with the envelope wrapped around it. This is the envelope, and here is the actual source message. Now, the envelope can contain very useful information. Admittedly, we never need to uh, access that information, but this can be useful in many scenarios. So that's the default behavior. Now, in an SNS topic that's receiving, hundreds of thousands of messages, then the amount of space that's consumed by this envelope can be significant, and all of this has to be transmitted across the network, etc., etc. So if you know that there is nothing in the envelope that's of use to you in terms of the lambda that's consuming the messages, then you can tell the SNS service to exclude the envelope um, in its wrapping. And so if you do that, well, how do you do that? Well, if I go back, it's a simple switch when you create the subscription. It's at the subscription level rather than the topic level. When you create the subscription, you can add this property here. And this is essentially saying, uh, when you set this property to true, you're saying do not include the envelope. Or put it another way, leave the message in its raw form. Don't actually wrap it with any extra metadata. So if you do set that to true, then what you get is this. Sorry, what you get is this. Okay, so the body now is just the message itself. If you contrast this with this, you can see the difference between the two. In both cases, I'm looking at the body of what we're looking at here now is the console log from the Lambda that's connected to the queue. Okay, uh, so this is the envelope and the message. Whereas when I turn on that switch that I showed you, you don't have any envelope. You just have the message itself. And if we just take a quick, if we go back to here, I suppose, and if I go into my CDK code, then which one is it? This only applies now when you've got an SQS queue that's a subscriber, and then you've got a Lambda connected to that queue. It doesn't apply to the case when the Lambda is a direct subscriber. So it's this one here. Thought I had it in there. Oh yeah, there it is there. So if I enable that line, the rest we needn't worry about. And if I do my CDK deploy, and I'm going to send a second message. And then eventually when that message gets through to the Lambda that's connected to the queue, we can see that that message won't have any envelope around it. And before I send the message, go back to so this is, this is the message that was received by the Lambda that's connected to the queue. And here's the body of the message. And all of this stuff here is the envelope, and buried within the body is the actual source message. So this is, an example when the envelope is there. Now, if I send the message again, we do have to wait a couple of seconds for that to get through to my Lambda. I won't have a new log group. It's going to be the same log group, and it's going to be this log group here. And I'll just do a couple of refreshes. My logs are gone. Let's see, do another refresh. My stream seems to have disappeared. Let's give it a chance. Okay, it's just refreshing very slowly. Just want to check to see what network am I on. Wow, that is slow. Okay, I've got two log streams now, so just based on the timing, this is the more recent one. And there's the body of the message, and there's no envelope around it, which is what we expected. Okay, so do switch off the envelope, I guess, is uh, the point that I'm trying to make there. If you can disable the inclusion of the envelope. Now we do have two scenarios. It seems you've one scenario where the Lambda is a direct subscriber to a topic, and the second scenario is where the Lambda is a consumer to an SQSQ, and that is the subscriber to the topic. So the obvious question is, well, which one should you use? Should you use this approach or this approach? Are there advantages and disadvantages of one over the other? And again, I had to dig a little bit deep into the documentation to find the answer to that because it's an obvious question. Uh, and the answer that I can get from looking at the documentation and indeed Stack Overflow, which is probably even a better source for explaining the differences between the two. So the main disadvantage of using this approach, where the Lambda is a direct subscriber to the SNS topic. Number one, there's no batching is available, and I've tried to explain that to you. Even though when you look at the console log of the event that's received by my Lambda subscriber, it does seem to suggest that it could be receiving an array of messages, but it never does. So there's no batching. So that means your Lambda subscriber is going to be executed once for every message that's written to your topic. Now, if the volume of messages is low, then that's not a big deal. If it's high, it's certainly an issue. Number two, you've no control over concurrency. You might remember when I was talking about concurrency in relation to SQS, the SQS service automatically kind of ramped up the number of concurrent executing instances of your Lambda consumer to cope with the volume of messages that were being sent to an SQS queue. That doesn't work with the SNS service. So if you've got a Lambda that's a direct subscriber to an SNS topic and you've got a high volume of messages, all of the messages need to be processed by one instance of your Lambda function. And that's kind of what I'm saying here. What else? Your Lambda function is, oh yeah, you remember when I was talking about SQS, we had this dead letter queue or DLQ mechanism, and that was there to handle error scenarios when your Lambda either threw an exception or it timed out. You could eventually send those batch of messages in the case of SQS. The kind of faulty batch of messages would eventually finish up in another queue, the DLQ, and you could have a Lambda then that deals with those error cases. You don't have that available to you in SNS. At least it's not built into the SNS service. But of course, your Lambda that's a subscriber to an SNS topic, it may well throw an exception. So how do we handle those exceptions? Because we do have to handle it. The SNS service has no mechanism for dealing with them. The solution actually is here, like the DLQ has to be built into the Lambda rather than it being available automatically within SNS. And I'll show you how to do that in a moment. So there are all the disadvantages when your Lambda is a direct subscriber to your topic. And implicitly, these don't apply with the second scenario. The only advantage of this approach here is this one, right? It gets executed much quicker than, this Lambda gets executed much quicker than this Lambda. So if the nature of the messages that are being sent into your SNS topic are such that they need to be processed as quickly as possible, then you should connect your Lambda directly to the topic rather than via an SQS queue. So I'm saying down here, it's good for time critical processing. That seems to be the only use case where your Lambda as a direct subscriber is advantageous. Okay, so that's kind of, you won't be in a situation in this module anyway of deciding whether I should use this approach or this approach, but certainly in industry, these are the factors that weigh up whether you take one approach over the other. Back to core SNS. SNS has something called a delivery protocol and policies. What do we mean by these delivery protocols and policies? It essentially kind of dictates how SNS tries to deal with certain error scenarios. So first of all, we're saying that SNS defines a delivery protocol for each delivery. SNS defines a policy, defines a delivery policy for each delivery protocol. The policies define how SNS retries the delivery of a message when either a server-side or client-side error occurs. When a server-side error occurs. So what we're trying to get at here now is SNS, as I said, it pushes messages out to its subscribers. But what if the subscriber service, whether that be the SQS service or the Lambda service, supposing it's not available or for whatever reason it's not responding? I'm talking about the service now, not the actual SQS queue or Lambda function. So let's take one example. I've got a Lambda that is a direct subscriber to an SNS topic. The delivery protocol in that case is the Lambda service. So what happens when SNS tries to send a message to the Lambda service with the intention of that service sending it on to an actual Lambda instance? But the Lambda service is either not available because of network errors, or maybe the server that the Lambda service is running on is temporarily down. Either way, the Lambda service is not responding. What does SNS do in that case? Does it just forget about it and throw the message away? Clearly, that would not be good. It turns out that it retries sending the message multiple times. Now, and that retrying is what we call the delivery policy. And maybe if I just go on to the next slide. This is actually taken straight out of the documentation. And what it describes is the delivery policy for the different delivery protocols. Now, the protocols are kind of listed here, and the protocols really are either related to different services. So the only one we're interested in is, let's see, is here and here. So our delivery protocols that we're interested in is the Lambda protocol and the SQS protocol, because they're the two types of subscribers that we deal with. But you can have other subscribers, and there are other protocols for those other subscribers. Down here, actually, a subscriber could also be something that exists completely outside of the AWS platform, because you might remember when I started talking about these messaging services, the original idea of these messaging services from AWS's perspective anyway was to facilitate intercommunication between applications that ran on-premise servers that didn't run in the cloud at all. So down here, we're talking about delivery protocols related to external subscribers. So we're not interested in those. We're only interested in these two here. And what you see over here then is the policy that the SNS service will follow if it fails to deliver a message to either a Lambda service or to the SQS service. And if you just kind of read across, you can see if it fails the first time to deliver the message, it tries 3 more times without any delay between them. Then it tries 2 more times with 1 second intervals between the attempts. So it's now tried 5 times. Then it tries 10 more times with what's called an exponential backoff delay between each one. The exponential backoff, the way that works is, I think it starts with a 2-second delay, then it doubles it to 4 seconds, then it doubles the delay to 8 seconds. So it's doubling the interval between its attempts to send the message. So it tries that for 10 more tries at delivering the message. So we're up to 10 plus 2 plus 3, 15. If it still can't deliver the message, now it's delivering the message to the receiving service, okay? Because, as I said, the service is not available because of networking issues, or the server that the service is running on is temporarily down, or maybe the service is being overwhelmed and cannot respond. But if it still fails, it's going to continue on for another 100,000 times over a period of, does it say, with 20-second intervals, 20 seconds apart. If it still can't deliver it, it keeps going for approximately 23 days. Okay, so it doesn't give up easily. So it keeps on trying and trying and trying to deliver the message. Now, if after all of that, it still cannot deliver the message to the subscribing service, AWS service or the SQS service in our case, then it does give up. So it doesn't keep going indefinitely. Then it does give up and it essentially throws the message away. Or it will put the message into a dead letter queue, provided you have defined a dead letter queue for the particular topic. So I did say a number of slides back, I think there was a very first slide, if I go right back, I might be permitted to go all the way back to Let's see, where do I mention it? I thought I mentioned it somewhere. Yeah, here I'm talking about that the SNS service does have a DLQ facility, but it's not like the DLQs work the way they work in SQS. So the only time SNS will use a dead letter Q, if one is defined for a topic, is when, after trying to send the message to the subscribing service over a period of 23 days, I think we said, wasn't it? If it still can't deliver the message, then it will put that message into the DLQ. And maybe you've got a Lambda that's reading messages from that queue. So you would imagine that it's a very, very rare cases that messages don't actually get delivered eventually to the subscribing service. But they do provide a fallback mechanism should that occur, however rare it may be. Right. Let's go back to where we were. Right. So that's this idea of delivery protocols and delivery policies. Now, and this only relates to SNS trying to send the message to the receiving service. But let's say in the case of Lambda, if it delivers the message successfully to the Lambda service, then the Lambda service has to forward that message on to your Lambda handler. And the way it does that, as we know, is it actually invokes your Lambda function and passes it an event object, and the event object within it contains the message. But what if while the Lambda function is processing that message, it throws an exception? Who deals with that? You see, whenever you're talking about asynchronous communication, and that's what these messaging services are all about, to decouple your compute components. That's fine, the decoupling works successfully, but you always have to remember, what if an error occurs in one of your compute components while it's processing a message? Somebody has to actually deal with that, or you need to build that into your application, the kind of error handling. So bringing that back to what we're currently looking at, our Lambda service has received a message from the SNS service. The Lambda service passes it on, invokes the Lambda function, and the Lambda function throws an exception or times out. What happens next? Because now it's the SNS service is now out of the equation. It has done its part. Now the Lambda service actually must deal with this second scenario. So it's the responsibility of the Lambda service to handle these kind of errors cases. And so how do we kind of program that? Um, well, you do it kind of at the Lambda level. You can actually define a DLQ and link it directly to a Lambda function. So I'm saying here, when the SNS invokes a Lambda function, although, as we know now, SNS does not invoke the Lambda function directly, it goes via the service. When it invokes the function, or when the Lambda function eventually is triggered, SNS does not wait for the function to respond, because there's an asynchronous link between SNS and your Lambda function. So SNS is not waiting for a response. Therefore, the Lambda service must handle any function failures, as I've been saying. So if we take this simple architecture, again, SNS topic, we're going to write messages to the SNS topic, and we're gonna have a Lambda function that's a direct subscriber. But I'm going to force my Lambda function to throw an exception because it's going to examine the message and it's going to throw an exception when the message doesn't match the structure that it's expecting. And I'm going to link a DLQ to this Lambda function. And so the DLQ will actually receive the faulty message that it got from the topic. And then I have another Lambda that's polling this DLQ as before. Let's look at that case study. So again, we'll just actually what I'm going to do is the following. I've already deployed this and I'm going to publish a message into the topic because it actually takes quite a while for it to work its way through. Let me go back to here first, do a cleanup. And back to here. So my topic ARN is here. So let's open up the README. Now, if I just look at this here, this is the Lambda. That's a subscriber to my topic. And you can see here, it's checking to see that the message that it receives has an address property. And if it doesn't, it throws an exception. And the message that I'm going to send is this one. But I'm going to take out the address property. Okay, and let's send that message. So I let it work its way through. Let's just look at the CDK code. So again, the architecture that we want to set up is this architecture here. SNS topic, Lambda subscriber. The Lambda has a DLQ linked to it directly, and this DLQ has a Lambda consumer. Yeah. So here's our topic. Here's the queue. That's going to be the DLQ. Now, this is just a standalone queue. It's not linked to another queue, but it's just a standalone queue. Here's the Lambda that is the subscriber to my topic. But notice this property here. And what this property does is saying that if my Lambda fails, then I want Um, I guess it's the actual event object that, although I have to check that now. Let's for now, let's assume it is. It's the event object that this Lambda received. It should put that into a destination, and the destination is my SQS my failure queue, as I call it. So that's the setting that links. You can actually link to any type of destination, but in this case, we're linking an SQS as the destination for sending the error um, that occurs when my Lambda fails. And the rest of the code down here then is just, well, okay, this Lambda here is the Lambda that's processing the messages from the failure queue. And I don't think there's anything, I think it just probably does a console log as usual. Yeah, console log, and it just goes over the messages in the queue and console logs them. So no surprise, nothing interesting happening there really. And all of this code here then is just connecting up my compute components to the various other resources. So we don't need to really look through that. So again, as I said, this is the Lambda that is going to throw the exception. Now, the way it actually works is, I go back to here, SNS will successfully deliver the message to the Lambda subscriber. So SNS is now out of the loop. The fact that the Lambda is going to throw an error, that's not going to be reported back to SNS because there's an asynchronous link between these two. When the Lambda function throws the exception, that exception is caught by the Lambda service. And what the Lambda, so I'll put a box mob representing my Lambda service. What the Lambda service does is it retries. It actually invokes the Lambda function 3 times. And if after the third invocation, my Lambda function is still throwing exception, only then will it write to the DLQ, which will eventually be picked up by this Lambda. So when we look at the log stream of this Lambda here, we will see that confirmed that it has actually been invoked 3 times. So let's look at the log groups. So I've got 2 log groups for my 2 lambdas based on the name. This is the log group for the Lambda subscriber. And you can see that it ran the initialization code for the Lambda subscriber. There actually wasn't anything in it, but it does that anyway. Then it starts the execution of my Lambda function. And here is where, is this it? Here's where it's throwing the error, throwing the exception. Then it ends. And as I predicted, the Lambda function is executed for a second time. It's a warm start in this case because it doesn't need to run the initialization code. It fails again here. And it tries to execute it a third time. And eventually, because it fails again, it eventually gives up. So that's the 3 attempts that the Lambda service made to, or the 3 attempts by the Lambda service to get the message processed. successfully, but it wasn't didn't come through. And so eventually it put the message into the DLQ, which is why I've got a second log group, which is this one here. This is the log group for the Lambda that's polling the DLQ. And if we look at it just does a console log. And if we look at, so this is the event that it receives, and somewhere in there is my original message. Well, this here actually, again, is our SNS envelope around my message. So if I just do a lookup, let's say for my name, let's see, why is it getting so many hits at that? Oh, there it is there. And there's no address in it. So what's that telling me? It looks like, yeah, it looks like it's actually giving me just the SNS message. That's what's being, if I go back to the slides, what this Lambda receives is the actual SNS message uh, that this Lambda received. Or maybe what this actually receives is the entire event that this one received, which caused it to throw the exception. Yeah, that's actually probably a better, yeah, the the event object that this one here receives is the exact same as the event object that this one receives. So this one here has the full picture of what caused this Lambda to throw an exception. And, I didn't put any processing in there, but uh, all really interested in is that this DLQ mechanism here actually works for us. So that's how you build in error handling into a Lambda that is a direct subscriber to an SNS topic. How do you build in error handling to a Lambda that's connected to a queue, which is connected to a topic? In other words, if you go back to here, how do you build in error handling for this Lambda here if it happens to throw an exception? Well, the answer to that is you create a DLQ that's linked to your SQS queue, and we've talked about that before. So uh, there's nothing new in that case. Okay, that's error handling when you've got a Lambda that's a direct subscriber. What's next? Next is filtering. What are we doing on time? Sorry, just to go back to that example. Well, okay, just for the sake of it, but if we go back to the message and we put our address back in, I guess this is fairly obvious, and we send that, what happens back here? If we look at this one, do a refresh. And we've got two log streams, which makes sense. But whereas in the log stream that we were looking at a few moments ago, I showed you how the Lambda service kept retrying, but of course that shouldn't occur in this case because the Lambda isn't going to throw an exception. And so if we look at which log stream is it? It's this one. It's just a kind of ordinary case, there's no exception thrown, so it just goes through the normal cold start my Lambda function. There's no exception being thrown, no error being thrown, and it works its way through successfully. Okay, so no surprises there, I think. The next thing we want to look at is filtering, and the image kind of shows you what we're trying to achieve here. So you've got a publisher, or many publishers that are sending different types of messages into my topic. There's no sense that a topic message has to follow a certain schema. That's not the way these things work. So, and the color scheme there is kind of reinforcing this idea that there are different types of messages being written to my topic. But over here are my subscribers, and again, they happen to be all SQs, but it could be any types of subscribers over here. But the idea is that we want the subscribers to receive only certain types of messages. So it looks like we want this subscriber to receive all the messages, whereas this subscriber only receives I don't know what colors they are, but only certain messages. This subscriber only receives certain types of messages, and so on down. In other words, we want to filter the messages before they actually arrive at the subscriber stage. How do we do that? Uh, and we define the filtering at the subscription level. Like there's the publisher, the subscriber, and the link between the two is what we call the subscription. And it's at the subscription, or sort of in the subscription resource, that's where we define our filtering policy. So that word policy appears again. So a filtering policy can be based either on what are called message attributes, which we haven't seen so far, but we will in a moment, or the filtering could be based on the body of the message. So in other words, you can filter based on the property of the JSON body, or you can filter based on the property of a message attribute. Attributes are just a separate set of values, if you like, separate from the message body, a separate set of values that we can associate with a message. And those values are described in JSON form, key value pairs. And so you can define filtering based on one of the properties of those key value pairs within my attribute JSON structure, as opposed to the body JSON structure. Now, whether it's the body or the attribute structure, there's a set of what are called filtering criteria that you can use. Or in other words, the filtering criteria is how you encode the nature of the filtering that you want to have carried out. And it's reasonably simplistic, really, but it seems to serve most cases. So one is what are called string filtering. So if we just take the case where we want to filter based on one of the attributes of the body of the message. If your filtering criteria is a string filter, then that's where the attribute value, the property value, the property of the body, its value is a string, and you can specify an allow list filter. So the allow list would list a set of string values, and you are essentially saying, I only want messages where a particular property of the body has a value that is one of the values within this allow list. Alternatively, you can specify a deny list. This again is going to be an array of strings. And here in the deny list, you're saying, I'm only interested in messages where a particular property of the body has a value that is not in this deny list. So it's kind of the negative case. In the deny list, you're specifying values that you do not accept. In the allow list, you're specifying values, the only values that you will accept for a particular property of the body. And the final option is a match prefix. So you're saying that you want the beginning of the body property to have a particular prefix value. But it's a string in each case. The actual property of the body has to be a string property. If the body property is a numeric value, then you have these options. You've got an allow list, greater than, less than, and there's a few other between. I think maybe that covers all of them really. Finally, the exists filter, all you're saying is in the exists filter is, I'm only interested in messages where a particular body property exists. I don't care what value it has. It just must be one of the properties of the body of the message. And if it doesn't have that property, then I'm not interested in passing that message on to the subscriber. So 3 types of filtering criteria: string filtering, numeric filtering, or exists filtering. Right, let's look at an example. Now, I've picked the message attribute as the first example because it's actually easier to read the code for this than it is for the body filtering. If I go back to the previous slide, like I said here, right, that the filtering can be based on a property of the body or a property of a set of attributes that are associated with the message. So there's 2 things we need to find out. First is, how do we actually define the attributes associated with a message? That's actually quite straightforward. And secondly, then, how do we specify a filter based on those attributes? So again, here's my simple architecture. So again, I'm going to use the CLI as my publisher, SNS topic. I've got 2 subscribers as before, and I've kind of put the filtering here. So this is kind of where you define the filtering. It's between the topic and the subscribers. And this is what I'm calling the subscription, I suppose, if you like. And what I've decided is that the filtering policy that I want to define here is that the Lambda subscriber, this guy, the Lambda subscriber should only receive messages with a user type attribute set to the string student or lecturer. Okay, so we're just focused on this one for now, this subscriber here. Ultimately, later on, we'll look at the filter that's here. So for now, we're just interested in this filter here. So this filter has to stop messages that include an attribute called user type, where if that attribute essentially contains the string student or lecturer, if it's either of those values, I want that message to get through. If it doesn't have either of those values, I do not want that message to get through. And this is how we do it. So let's supposing my message body is this one here. We're not really interested in the message body. Here are the message attributes. And as I said, you encode your message attributes in JSON form. Let's not worry about what constitutes an attribute. An attribute can be anything, just depends on the nature of the messages themselves, I suppose. But the attribute key value pairs because that's all they are. The keys can be anything, the values can be anything. So it looks like in this case, I've got two attributes. I've got a user type attribute and I've got the source attribute. And this is how we actually encode our attributes. We've got to say what type is the attribute. So S here means it's a string. And this is the value of the attribute. So it has the value lecturer in this particular case anyway. The user type property, the user type attribute has the value lecturer. There's another attribute as well, and I've just put that in there, but we're not actually using it for now because that wasn't, this other attribute, the source attribute, wasn't mentioned in my filtering uh, policy, and I'm not talking about source here. I'm only talking about user type. Okay, and here is how we write our filters. So it's when we try and add a subscription to a topic, and there's a property. Let's see. Oh yeah, so it's a Lambda subscriber in this case, and so there's this attribute called filter policy that you can set for a Lambda subscriber, and you could kind of make sense of what we're trying to get at here. The particular attribute is user type, so that has to match one of the attributes over here, which it does in my case. In this case, I'm using the allow list filter criteria because that was the simplest one. Because in my filtering policy, again, I go back to here. The filtering policy said I'm only interested in messages where the user type is that or that. So I've got my allow list, which says that or that. And then SNS does the rest. So let's try and run this. Now, which example is it? It's the other one. So we've seen this project before, but if we just fast forward to this part here, which I showed you on the slides, and if I now enable this, okay, and the message I want to send is the same as before. So here's my message, and I've got my attributes in a different file, which is somewhere here. You've seen that on the screenshot. So I've set it to lecturer. Okay, and I've already deployed the stack from earlier. Let's just go over to CloudWatch and do a cleanup. Can't believe how slow it is. Now, what I'll actually do is the following, actually, probably be a slightly better illustration. Supposing I set the attribute to, let's see, I'm going to change this to admin. That would mean that the message is never going to get through because the filter is going to stop it. And I'll change the message to Dermot O'Connor. I'll go admin. Yeah, and let's send that. Now, This is how we're going to send it. So I need to change the ARN. Which one is it? It's this one, isn't it? Sorry, it's this one here. I need to change the ARN. Right, so send the message where the attributes is contained in this file and the message body is contained in this file. And I'm going to send a second message. Now the first message is not going to get through, so I should not see it. But I have sent it. And if I now go back and change my message attribute, change it back to lecturer, and I'll change the message body so we recognize it. I'll just get rid of admin. Now I'm going to send that message. Back to CloudWatch logs. Now, if the filter wasn't working, I should receive two messages. Okay, there's two log groups because there are two subscribers, but we're not interested in the SQS subscriber at this stage. We're only interested in the land subscriber. So that's this log stream here. And I sent two messages, so I should really see two invocations of my Lambda, but I don't. I only have one invocation. Uh, yeah, no, okay. Oh, I've got two invocations. How come? Let's just do a refresh on that. Not sure why I've got two invocations, but let's drill into it. Oh yeah, so the first thing actually is just to show you, this is where you can find the attributes of a message in the event object as well. So here are the attributes appearing here. And so the attribute had admin as the user type, but that should not have gotten through. Wonder what I did wrong. Let's see the actual message body. Let's just follow on anyway. Here's the second invocation, which I wasn't expecting, but let's expand that. Yeah, user type is lecturer. And they're just the attributes. The actual message body is there as well. If I can find it. Where is the message body? Oh yeah, there's the message body there. Now, this message up here should not have gotten through. Let's go back and find out why that didn't work. Oh, I know why it didn't work. I never redeployed after I changed the CDK. That wasn't clever. Let's go back to here. I changed my CDK code and I didn't redeploy. Let's just quickly, do we have time? Yeah, just about. CDK deploy. Clean up my logs while I'm waiting. I've got to go back and change all these again. So be it. Change this to admin. Change my message to admin as well. Now send the message. Then the second message where the admin isn't there. Back to lecturer. And my second message. Now, this time, we should only see the lecturer one coming through. Again, we're only interested in this one. Do a refresh. Right. Yeah, this time now there's only one invocation of my Lambda. So there's a cold start here again. So it's a different micro VM, but it is only executed once. And so if we look at the console log of the event, we should see the lecturer one. Yeah, that's what we're getting there. So we never see the admin message, and the body of the message is there. Okay, so the filtering has actually done what we wanted it to do. And we could apply a similar filter. I won't get a chance to do it now, but if we look at the CDK code, you can apply a filter as well to the SQS subscriber. This is the SQS subscriber, and here's a filter for that. But I'll talk my way through that the next day with you. Okay, that's all I want to look at today. And again, to go back to the labs, you need to work your way through this lab to completion and submit it. But you can see here, I don't have anything on filtering, for example, and filtering is going to be a significant part of the second assignment, second and last assignment. So I'll give you some simple little projects that illustrate filtering so that you can get to essentially play with them and see how they work, and then hopefully apply that in the assignment. Okay, that's all for today. So I'll touch base with you during tomorrow morning's lab. Thanks. Bye-bye.